Hey everyone, welcome to homework 6.4. Today we reviewed the mean absolute deviation, or the MAD, and the interquartile range, or the IQR. So we're going to start with this practice problem where we have lemons growing on Mary's tree. There's only 4 data points and it asks us to first calculate the mean. So to calculate the mean, since there's only 4, I'm just going to go ahead and add them together and divide by 4. If I had a larger data set, then I probably would use the calculator function, but I don't really feel the need to do that in this case. So here the average is 13. So I'm going to go ahead and mark 13 as my mean or my average. It says calculate the distance between each data point and the mean. Find the absolute value of the difference between the data point and the mean by creating your own table above. So the mean is 13, right? And so then the distance from 13 and all of these points is 10 here, 2 here, 8 here, and 0 here. Now, when we're looking for these distances, they should be positive. So you just can subtract the bigger number. Really, technically, you're supposed to subtract the average minus the actual number. And then, so in some cases, you would get a negative number, but you take the absolute value of that, which is going to make it positive. So these are my absolute deviations right here. So to find the mean absolute deviation, I need to average them, right? Find the mean. So 10 plus 2 plus 8 plus 0 divided by 4 is 5. So here my, this is 20, and then divide by 4, so that's 5. So this is the mean absolute deviation, or MAD. Okay, and this is a pretty simple example where there's only 5 data points. All right, the next part tells us that this is about the variation in data and how spread out the data is from the center, right? So a smaller MAD means there's less variation or the data is less spread out. A larger MAD means more variation and the data is more spread out. Would you expect the ages of students in Jefferson to have a smaller or larger MAD? Why or why not? Well, generally our students are between like the ages of 11, 12 to 14, maybe max 15. So, and the average, right, would be our 7th graders, which are generally 12, 13. And so this I would expect to have a smaller MAD because it's only middle school. Now, if we were looking at K through 12, right, then we would have a larger MAD because the older kids would be further from that middle age group. Number 2, would you expect the ages of all the people in your extended family, grandparents, aunts, cousins, to have a smaller or larger MAD? Why or why not? So I would expect, or not why or why not, but why. So I would expect them to have a larger, and in my family, that's because like the oldest person right now is like 80 something, right? And then the youngest person is my cousin's about to have a baby. So, right, we have like wide range. And then the average age, I'm actually probably the average age, like middle-aged person. So baby is 40 years different than me, and the 80-year-old is also 40 years different than me, right? So this would have a larger MAD because the average middle-aged person, right, is around 40, and then we have people who the grandparent is super much older and the babies are much younger. All right, the data set represents the number of errors on a typing test. So these are people who took a typing test and the number of errors that they got. Notice that this data is already in order from least to greatest. It says, what is the median? Interpret the value of the situation. So again, I like to just go ahead and cross off, right? There's 2 on each side, 3 on each side, 4 on each side. And that leaves me then 4 crossed off. That means me a 2 in the middle. And the average of those 2, or the median then, is 9. So the median is 9. And that means the middle number of people scored a 9. The IQR. So this then is the median, right? So then looking at the median of the 5 numbers on either side, the median would be 8 here, and the median would be 10 here, okay? And so because the median is 8 here, and the median is 10 over here, then the IQR would be quartile 10, right? Quartile 3 is 10, minus quartile 1 is 8, so the IQR is 2 here, okay? So again, we have an odd number on either side of the median because it's 5 on each side. So the middle number is that third number here and that third number here, which is 8 and 10. So this is quartile 1 and this is quartile 3. And our IQR is quartile 3 minus quartile 1. All right. Number 2, the data set represents the heights in centimeters of 10 model bridges made for an engineering competition. All right, so these are the heights of the bridges. What is the mean? What is the MAD? Okay, so we can again calculate. For the purposes of this, I'm going to remind you how to use your calculator. So I'm going to edit my list. If you already have values like I have up here, you can go up 1 to L1, press the clear button, and then press enter, and it will clear all the values, okay? So I'm going to enter my values, 13, 14, 14, 16. There's 4 16s, so 16, 16, 16, one more, 16, okay, and then 18, 18, 19, 18, 18, 19. All right, so now I'm going to go to Stat, Calculate, One Variable Statistics, List 1, and here we go. So my mean here is going to be 16. All right, now the MAD means I need to find the difference of 16 and all of these numbers. So I'm going to write that next to it here. So that's 3, 2, 2, 0, 0, 0, 0, 2, 2, 3. So just looking at those numbers, do you expect this to be a small MAD or a large MAD? Well, it's probably going to be pretty small. So let's go ahead and take a look. Now again, you can put these other values into L2 if you'd like. So we can do 3, 2, 2, 0, 0, 0, 0, 2, 2, 3, right? And then now we have our other values. And so then what I can do is I can press Stat, Calc, One Variable Stats, and then instead of L1, I can choose L2, okay? And so that would calculate the average of these here. So that is a way to help you find your MAD once you've gotten all of those individual values. All right, and so this is going to be 1.4. All right, I am going to show you right now, for those of you who are watching, another way that you can find the MAD. So this is a little bit complicated, so you know, you might need to watch it more than once. So you're going to second, Stat, which is list, right? That blue list button. I'm going to go over to math and I'm going to choose mean, so 3. Now I want to choose that, but I need the absolute value of it. So I'm going to go to second, catalog, she'll select absolute value of, and then I'm going to do second, list 1 minus second. So this is going to be each item in list 1 minus, so I'm going to do second list calc, or sorry, nope, sorry. Second, quit, that didn't do it correctly. So let me go back over here. All right, so minus second list, there we go, math, and I'm going to choose mean again of list 1. So that's second 1 is list 1. Close my parentheses, okay, and then hit enter, which is 1.4. So you get the same thing here. So you can do it this way. It's just, honestly, it's probably going to take you as much time, right? But you go to second list, go scroll over to mean, to math, and then select mean. And then you need it to be absolute value because we don't want any negative. So we go to second catalog, choose absolute value. It's the first one there. Second L1 minus second list, scroll over to math. We're going to choose the mean again of list 1. And what this is doing is subtracting every value of the list minus the mean of that list, right? Minus the average of the list. So it's just calculating. Now, if you know the mean is 16, for example, You can also do second list, scroll over the math mean, okay, and we can do second catalog absolute value of second L1 minus, in this case, we know the mean is 16, right? So we can do minus 16, or actually, no, we would need to do the average, so we can't really do that. So you would at least need to find the average of L1. Oh no, you can still do that. Okay. And then let's see, this should work. Yeah, we get the same thing, right? Because 16 is the average of it. So we're subtracting each value minus 16, getting the absolute value, and then taking the average of that, right? And so we get 1.4 again. So that works as well if you know what the mean is. Instead of doing all this mean of L1, you can change it that way. But that's how you use your calculator to find it. So again, you can make a second list and find it this way, find the average of L2, or you can just go ahead and do the other way as well. That also means we could do second, since we put the list in there, list, scroll over to mean, and do second L2, right, since we put those values in there, and we'll also get the same thing. Okay, so you can use that second list math to find the mean of a list of numbers. All right, so this number 3 says describe the shape of the distribution shown in the dot plot. Well, in this case, less of our data is on the right, more of our data is on the left. So this would be right or positive skewed. Okay, because there's less data on the right, that right side is going to pull the mean up, even though the median will be on the left. Number 4 says the plot shows the weight in grams of several different rocks. Select all the terms that describe the shape of distribution. So we can say that this has 2 peaks, right? So this is bimodal. We can also say that it is symmetric because along this line there, all the other sides are equal, right? It's symmetric. This matches this matches this, so forth and so on. So those are the 2 that we can select for that. It's not uniform because they're not quite all the way straight across. If maybe only one of them was a little bit higher than the other, we could maybe say that. It isn't really skewed because it isn't leaning one to one side or the other. It's pretty evenly across both sides. And then it's not bell-shaped because we have this valley in the middle. Instead, we have 2 peaks. Number 5, the dot plot represents the distribution of wages earned during a week period by 12 college students. This is how much these people have earned. So one person earned 112, one person earned 113, 3 people earned 116. What is the mean? Interpret the value based on the situation. So you know what? Let's go ahead just so that we're practicing using our lists. And I'm going to go up and clear, enter. And I'm going to go ahead and clear list 2 just so that I don't get confused there. All right. So list 1, I have 112, I have 113, I have 3 116. So I need to enter all 3. Remember, when you're looking for the mean, median, mode, etc., you need to look at all the data sets. So 118, or all the data points in the data set, rather. 119, there's 2 of those. And then there's 3 124s. 124, 124, 124. Okay. So, and there's 12 college students. So if I go back up, I should have 12, right? I went down. That's why it says 13. So there's 12 data points. All right, so I'm going to calculate the mean. Now, remember, there's 2 ways I can do that. I can press stat again. I can press calculate and 1 variable stats. I need to change this to list 1 and then enter, 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 calculate. And then my mean is 118.25. Now, I can also calculate that by going to second list. So going over to math. Oops, that's not what I meant to do. Let's choose a second list. Math, choose mean, and I'm going to second L1. And I get 118.25 as well. So we get that same answer either way. There's 2 ways to do that. Then the median, I'm going to go back to my stat because that's the easiest way to look at that, is here. And my median is 118. That's my middle number there. Interpret the value based on the situation. So for the mean, the average is 118.25, and then this is the middle number. half the people scored less than 118 or earned less than 118, half the people earned more than 118. Would a box plot of the same data have allowed you to find both the mean and median? So no, we could find median, not mean. It says the box plot displays the temperature of saunas in degrees Fahrenheit. What is the median? So this is just interpreting this as 118. Okay, that middle number. And then if I asked you for the IQR, you would take 124 minus 115, okay, which shows you how spread out this data is. So that's 9, right? And so the middle portion of the data is 9 values long, okay, which means that there's a decent amount of variation for these temperatures in the middle section of the data. All right. So your code word for today, we'll make it hot springs, since there was this thing about a sauna. Hot springs is your code word for today. If you have any questions, feel free to reach out. I'll be posting another video of your problems for CAPE.